Today we are doing lesson 5.5 slope. I can statements, I can find slopes of lines, and I can interpret slopes of lines as rates. All right, so slope tells us how steep something is, and it gives us a number to describe it instead of just saying very steep or not steep at all or completely flat. It gives us a number to describe it so we can compare different slopes of different lines. So slope is a vertical change, so how far up, over the horizontal change, how far over, and it's represented by the letter M. So M equals rise over run. Rise is how far up and down. Run is how far side to side. I'm just going to add in an extra up and down here. That's rise. Sometimes up, sometimes down. Run is side to side, left to right. If we are looking at order pairs instead of a graph, we can do it by subtracting with our x and y values. Our y-axis is the one that goes up and down. So if we were going to use subtraction here, we would say y2 minus y1. So that's if I have, let me write these off to this side, two ordered pairs. So here's my first one, here's my second one. The little 2's and 1's just represent if it's on the first ordered pair or the second one. And then same thing here, x second x value minus the first x value. And then you write it as a fraction or a ratio. And just like with other fractions and ratios, you need to make sure that your answer is in simplest form. Over here it says slope represents the rate of change. And like I just said, it should be written as a fraction in simplest form. All right, so now we are going to practice finding the slope of each line below. So we're going to start with this first line here. I like to draw a little step in to help me with my counting between my 2 points. So here was my first point, here was my second point. I'm just going to trace over them to make it a little more visible. Okay, looks like we went up 1, 2, 3. And then over 1, 2. So my slope for this first line is 3 over 2. Unlike fractions, where if we see something like this, it's an improper fraction because the top number is bigger and we make it a mixed number, we don't do mixed numbers for slope unless it's a story problem situation. So 3 over 2 is my simplest form. So 3 over 2 for this first one. All right, let's take a look at this next one. This line is pointing down. It's actually going to give us a negative slope because as we travel from the first point to the second point, we are going down. If we want to call this our first point, then we're going to the left, either down or to the left is a negative value. All right, so let's see. We went 1, 2, 3, 4, 5, 6. And then 1, 2, and then again it's going to be a negative because my line is pointing down from left to right. And then negative 6 over 2 simplifies to negative 3. Negative 3 is our slope. All right, let's look at this one on the bottom. This is a positive slope because it's going up from left to right. Here's where my first and my second points are. Okay, so let's see, I go up 1, 2, I go over 1, 2, 3, 4. So that's 2 over 4, and that's going to simplify to 1/2. So that is our simplest form right here. All right, so over here it says the slope of a line can be determined from a table by plotting units on a coordinate plane, so taking the table, putting it into a line on a coordinate plane, or by subtracting our coordinates. Subtracting coordinates. This is our formula for subtracting. All right, find the slope between the 2 points. I'm going to do my work off to the side where I have a little bit more space. Okay, so I'm just going to do problem number 1 over here. So I have 3 and negative 2 as my first ordered pair, and I have 4 as my second. Now it doesn't really matter which one's first and which one's second, but you have to be consistent when you set up your fraction. So 4 and 4, that's my second point, my x2, y2. So I'm going to put 4 on the top minus 4 on the bottom minus. I'm starting with the same point. Now I'm going to subtract the first point. My y goes on the top, which is my second order pair. So 4 minus negative 2 on the top, and then 4 minus 3 on the bottom. Now I'm ready to subtract. Boom, change to addition. Boom, change the sign. 4 plus 2 is 6. 4 minus 3 is 1. So my slope here is going to be 6. It can be a whole number. It can be an improper fraction. It cannot be a mixed number unless it's a story problem. All right, let's do the same thing for problem 2. I'm going to call number 1 my 6, 0. I'm going to call number 2 my negative 8, negative 1. So problem 2 over here. Okay, so I'm going to put my point 2's first. Negative 1 on the top, negative 8 on the bottom, minus my first values. 0 is my y, it's going to go on the top. 6 is my x, it's going to go on the bottom. All right, so negative 1 minus 0 is still negative 1. And then negative 8 minus 6, if I do boom, boom, negative 8 plus negative 6 is negative 14. Notice how I have a negative on the top and the bottom. They cancel out. It's like doing negative 1 divided by negative 14. A negative divided by a negative is a positive. So over here, I'm going to write positive 1 over 14. And I kind of wrote my slash there instead of my fraction bar like that just because I don't have a ton of space there. All right, so let's see this next one here. So it says the slope of a horizontal line that means completely flat is 0. If you are walking across a flat field, it has no slope to it at all. Only when you go up to a hill or to a mountain that you're going to have something that's changing up or down, and that will give you a slope. If we have a vertical line that's completely up and down, you're not going to be able to walk on that. That's not like a hill. So for that, we call that undefined slope if it's a complete vertical line. So if you have one of those, you don't have to actually calculate anything. You just write undefined or you write 0. All right, so I'm going to just adjust this a little bit. Remember, up and right are positive movements. Down and to the left are negative movements. All right, let's take a look at these last couple problems here. Plot a line that starts at the origin. That means 0, 0. Origin is 0, 0. And has the slope of negative 3 and label it A. Negative 3 is like negative 3 over 1. I'm just going to rewrite it over here so you can see it. That means I'm going down 3 and to the right 1. I always go to the right. So I'm going to go down 3, 1, 2, 3 over 1. Now I could have gone up and to the left, but I can only one part can be negative. So I'm just putting that on the top. Down 3 over 1. Okay, so those are the 2 points for my line. Now I could go the opposite direction. I could go up 3, 1, 2, 3, and to the left 1 if I want another point. As we draw lines, it needs to be a straight line. It needs to go through the entire graph space. So this is my line A. All right. Now it says plot a line that starts at 0, 4. So 0, 4 is 0, over 0 up 4. 1, 2, 3, 4. Here's 0, 4. Okay, and then it says has a slope of negative 3/4. So that means it's going down 3 and to the right 4. So 1, 2, 3. 1, 2, 3, 4. Again, connecting those points with a nice straight line, as straight as I can do it. B. All right. And then at the very bottom here, it says steeper slopes have a greater absolute value. So you might have a negative slope that's steeper than a positive slope. It's all about their absolute value. The larger the absolute value, the more steep it is. Okay, let's try some more problems. So try it. Graph 4 different lines, all with different negative slopes. Show each slope and compare steepness. Go ahead and pause the video for a moment. Try this problem. Okay, check your answers. I'm going to do some. Obviously, yours are not going to look exactly like mine, but they should look similar. So here's my green one first. I went down 2 over 1, down 2 over 1, down 2 over 1. And I'm going to connect. That's not a very straight line. You can always use a ruler to help you if you'd like. Okay, now I'm going to switch colors. Let's see, I'll go down 1 over 3. Down 1 over 3. Ooh, look, my lines overlap right there on that same point. Down 1 over 3. And if it helps, these negative lines are going the same way as the slant on a capital N. That's the direction that a negative line or in line with a negative slope is going to look. Okay, let's see, I'll do a slope of -1. Down 1 over 1, down 1 over 1, down 1 over 1. Okay, so I've got some points right here. All right, and let's see, for our last one, I guess I'll go here. And I will go down 3 over 1. I'll do it like this. Every one of your lines should go through the entire coordinate plane and should have arrows on the end. All right, let's see. Steep slopes will be represented with a fraction with a greater, and then these are our absolute value bars. We discussed that on the other side. Absolute value. All right, next one, it says sketch a sample or a few of each type of slope. Add a skier if you want. It may help you remember the directions and whether the value is increasing or decreasing. So go ahead and pause the video and sketch one of each of these. All right, let's check our answers. So positive slope, got to start with my coordinate plane. I think I'll set up all 4 of my coordinate planes here in blue, and then I'll switch colors for my lines just to make them stand out a little bit better. All right, there we go. Okay, so now I am ready to graph. Positive slope is going to look like this. From left to right, our line is going up. Negative line, again, looks like the slant on a capital N. Looks like this. Zero slope, flat like the floor. Horizontal line. Undefined slope. It's a vertical line up and down. So straight up and down, that is an undefined slope. Mine is slightly slanted. It's a little hard for me to draw with my tools here to be perfectly up and down, but undefined is perfectly vertical, up and down. Okay, order from steepest to least steep. So if we're thinking of these just like fractions or whole numbers, 3 is our greatest one. That's going to be my steepest. 3/2 would be next. That's like 1.5. 3/4 would be next. 3/4 is more than a half. And then 1/3, which is smaller than 1/2. It's going to be our least steep slope. All right, so let's take a look at the next type of problem. The table shows your earnings for babysitting. Part A, graph the data. Part B, find and interpret the slope of the line through the points. So the first thing I need to do is graph the data. So I need to draw in a coordinate plane. Here I have all positive numbers, so I only need a 1 quadrant graph. And when you are doing your graphs on your homework, I do prefer for you to have graph paper. If you don't have any, you can print some out. Okay, so I have my hours 0 through 10. I need to use consistent spacing here. I think I'm going to go up by 1s. Every line is a 1, but I'm only going to label every 2. 2, 4, 6, 8, 10. All right. And then over here, looks like going up by 10s would make sense. I'm going to skip every 2 line and label it with a 10. 10, 20, make sure your spaces are consistent and your numbers are consistent. 30, 40, 50. All right, now I'm ready to actually graph. So I have 0, 0 on my graph. I have 2, 10. I have 4 and 20, 6, 30, 8 and 40 and 10 and 50. So now that I've plotted my ordered pairs, I'm going to go ahead and connect my points with a line, extend that line through the graph. Now I'm not going to put an arrow on this end because that would extend into the negatives, which doesn't make sense for this babysitting situation. On your graph, when you're graphing for a story problem, you always need a title and label. So let's see, this is babysitting earnings. All right, I'm going to put babysitting, and then I'm just going to put money as my title. You could use the word earnings. Okay, hours is my X. Remember, my x-axis is this one on the side. And for that, I need to put a label. So I'm just going to squeeze it over here, hours. And then they tell me my y-axis, which is this one on the side, should be dollars. All right, so that's what your graph should look like. Any story problem, you need to have numbers on your x-axis, numbers on your y-axis. Your line goes through the entire graph with labels on the y and x-axis and a title at the top. So you need all of that. That is part A. Then for part B, we need to find and interpret the slope of the line through the points. Now you can pick any 2 points that you want. I'm going to pick these first 2. If I use subtraction, remember it's y over x, 10 minus 0 over 2 minus 0 gives me 10 over 2, which simplifies to 5. Or if I wanted to count rise over run, I can count up 10. Now I can't say I'm up 2, even though it's up 2 boxes. These 2 boxes are worth $10. So it's up to 10 and then over to 2. So that would be this, 10 over 2 simplifies to 5. I'm not done because it says to interpret, which means to explain. So what does 5 mean for this situation? Okay, so I'm going to write I earn $5 for every hour babysitting. That's actually my unit rate on this one. It's telling me how much for every hour. So I've got my slope and I've got something that interprets it. And I've got a graph with labels, a title, even numbers, evenly spaced numbers, and my points on my line. So that's all the things you need for this type of problem. All right, go ahead and pause the video and try these next two problems. All right, let's go ahead and check them. So in example 2, use 2 other points to find the slope. Does the slope change? All right, so I'm going to go back to example 2. All right, let's see. I'm going to pick these two this time, 840, 1050. $840, $10.50. Those are the points I chose. Okay, my y's are my second numbers. 50 minus 40 over 10 minus 8. Make sure you put the same ordered pair first. Same ordered pair second. Doesn't really matter which one goes first and which one goes second as long as you're consistent. 550 minus 40 is 10. 10 minus 8 is 2. Simplifies to give us 5. Does the slope change? No. You do need some work to support that answer. You shouldn't just have no. All right, let's take a look at number 4. The graph shows the amounts you and your friend earn babysitting. So for part A, it says, compare the steepness of the lines. What does this mean in the context of the problem? All right, so mine is green. My friend's is blue. The friend's is steeper. And in terms of the problem, that means my friend earns more money per hour. So that's what I'm going to put. Friends line is steeper. That means she makes more money per hour. I'm just going to abbreviate a little bit there. Okay. Part B says, find and interpret the slope of the blue line. So the blue line is this one right here. I like to use 0, 0 as one of my points. Makes it a little bit easier. All right. So let's see, if we went from 0 up to this part, this is 28. That tells us it's 28. So 28 is going to be on the top part. Extend this a little bit. Okay. So up 28. Now there are not 28 boxes there, but I know it's worth 28. It's in between 20 and 30. It tells me it's 28. Then I'm going over 4. 28 over 4, when I simplify, equals 7. So that's the finding the slope. The slope is 7. Interpret. My friend earns $7 per hour. All right, let's take a look at these next two. Graph the line that passes through each pair of points, then find the slope. Okay, so here I have negative numbers and positive numbers, which means instead of a one quadrant graph like I had in example 2, for this example 3, now I need to do a 4 quadrant graph. Anytime you have negative numbers to plot, you've got to do a 4 quadrant graph. You should have arrows on the ends of your axes. And try to do it as straight as you can right on those lines. Okay, so now I'm going to plot my points. Oh, actually, before I plot my points, my goodness, I need to label them. So let's see. It looks like I'm going -2 to +3. So I'm just going to go by ones. I'm going to skip every 2 lines. And then I'm just going to label by ones. -1, -2, -3. Okay, and then I have from -3 up to 4.5. Okay. So I think on this one I'm going to number by 2s. Make every line worth 1, but just label it every 2s. 4, 6, -2, -4, -6. Okay. Now I'm ready to plot my points. -2, -3 over to -2, down to where -3 would be, which is right here in between -2 and -4. And then 3, 4.5. So go over to 3, up to 4. This next line would be 5, so 4.5 is right about here. Make sure you connect that with a line that goes through your points. Okay, so now for finding the slope, I can count, rise, and run. So I could say, okay, we're going up 1, 2, 3, 4, 5, 6, 7. It looks like about 7.5. That's how far up. And how far over, let's say I'm going from -2 up to 3. So I can't just count the boxes on this one because there are 2 boxes for each one of these ones. On the top I could count boxes because every box was worth 1 whole. Okay, so 1, 2, 3, 4, 5. 7.5 over 5. Now, simplest form for a fraction, and we can look at the slope as a fraction, it's never going to have a decimal within it or a fraction within it. So for this one, to get rid of that decimal, we have to think about like what we did for decimal division. Decimal division, we moved the first number decimal over and we did the same thing on the other. Now that changes that slope into 75 over 50. And then we're going to simplify. So I'm going to divide both parts of my slope by 25. 75 divided by 25 is 3. 50 divided by 25 is 2. That's my slope. I could have gotten that 7.5 and 5 from doing subtraction. 4.5 minus -3 is 7.5. 3 minus -2 is 5. All right, now I'm going to do the same thing for part B. I'm going to set up my axes, 4 quadrants, because I do have some negatives to plot. Okay. Let's see, I've got fourths and halves to do. So I think I'm going to indicate each line as being a fourth. So 1/4, 2/4, which is like 1/2, 3/4. So every 2 lines I'm making a fourth, -1/4, 1, 2, -1/2, 1, 2, -3/4. Okay, then I'm going to do the same thing over here. 1/4, 1/2, -1/4, -1/2. All right, so now I'm ready to plot my points. Okay, -1/4 and 1/2. So I'm going to go over to where -1/4 is. I'm going to go up to where 1/2 is. I'm going to make my point. And then here's 3/4, -1/2. So over 3/4, down to where -1/2 is. Connect my points with a line. Extend that line through the graph space. All right, and then we're going to count our slope. So again, not each box doesn't represent 1 So I can't just count boxes on this one. I need to do some subtraction in my head or on paper. Since it's fractions here, it's probably easier to do it on the paper. Okay, so I'm going to do y minus y, x minus x to help me with my counting. On my y-axis, I start at -1/2. And then I go 1/2 up to the line, up another 1/2. This is a positive 1/2. That's going to give me 1. So that's kind of how I do it on my graph. Or I can do my subtraction. Let's see, if I start with this ordered pair, actually looking at the graph, that's a -1 because it's going down. I'll start with this ordered pair, -1/2 minus 1/2. Boom, change to addition, boom, change the sign, gives me that -1. All right, and then here, from side to side, I know I have 3/4 over to -1/4. So 1/4, 2/4, 3/4, 4/4, that's 1 on the bottom. And again, if you want to, you can show the subtraction. 3/4 minus -1/4. Boom, boom, 3/4 plus 1/4 is 4/4, which is 1, -1 over 1, the slope of -1. Okay, go ahead and pause the video and try these next two on your own. All right, let's check our answers. Okay, first thing I need to do is draw in my ordered pair. I'm sorry, my coordinate plane. Not ready for the ordered pairs yet. Okay, let's see, I've got to go 4, -4. Okay, 1, 2, yikes, 4, 6, -2, -4, -6. Make sure your numbers and your spacing are equal. -1 to 3. So let's see. 1, 2, 3. -1, -2, -3. Okay. Now I'm ready for those ordered pairs. -1, -4, over -1 down to -4. 3, -4, over 3 down to -4. All right, so my slope, 0. You can think the z on 0 can be extended to have that horizontal line. 0 slope, flat like the floor. All right, next one. Again, I need to start by setting up a coordinate plane. Make sure your numbers are spaced equally. All right, now I'm ready for my ordered pairs. 2, -2, 1.5. So over to where -2 is. Up here would be 1, so 1.5 would be about here. Just plot decimals the best that you can. All right, and then here -2, -2.5. So over -2, down -2.5. Connect it with a line. This one is undefined. And that's because it is a vertical line. If it helps, you can think that U, if you look at the side there, you could change that U into straight up and down.